Most organizations think deploy Copilot and suddenly they have an agentic workforce. They are wrong. Agents don't create discipline. They amplify whatever entropy already exists. Bad data, unclear ownership, and controls that only live in PowerPoint. So week 2 arrives, the first confident wrong answer hits the wrong audience, and adoption quietly dies. This is a 30-day roadmap that produces measurable outcomes, not a demo. 3 pillars in order: Copilot Studio orchestration first, Azure AI Search plus MCP grounding second, and Entra Agent ID governance third. And there's one design choice that prevents ghost agents later. It's coming. Define high performance in executive terms. Before anyone builds an agent, leadership has to define high performance in terms the business can audit. Not users loved it, not we shipped 4 bots. Outcomes. Because the platform will happily generate activity without impact. You can have thousands of chats and still have the same backlog, the same seller breaches, and the same escalations. That distinction matters. In executive terms, high performance means the system measurably changes 3 things: demand, time, and risk. Demand is volume reduction. If the agent works, fewer tickets get created at all. Not because users stopped having problems, but because the first interaction resolves them. That is deflection, and it's the only metric that actually hits cost. Time is cycle reduction. If a ticket still gets created, it should be created with better classification, better context, and fewer handoffs. That shows up as SLA reduction, faster first response, and higher first contact resolution. Risk is controlled behavior. The agent doesn't helpfully guess. It either answers with grounded evidence or it escalates. And every action is attributable to an identity with an audit trail. So for a 30-day window, the KPIs have to be realistic, measurable, and tied to one domain. Here are targets leaders can sign their name to. For service IT, 20 to 40% ticket deflection at LL1, 15 to 30% reduction in SLA time for the subset of tickets the agent touches, and 10 to 25% fewer escalations. Those aren't vanity numbers. They come directly from 3 operational levers: routing accuracy, containment boundaries, and handoff latency. For user productivity, 30 to 60 minutes saved per user per week in the target group. Not time saved in theory. Time saved as measured by reduced back and forth, fewer status check messages, and fewer "who owns this" detours. Also, over 60% task completion without a human handoff for the narrow workflow you choose, and adoption in the target group of 30 to 50%. If nobody uses it, it doesn't exist. For quality and risk, greater than 85% grounded answer accuracy on an evaluation set, 0 access violations, and audit logging enabled from day 1. Not after the pilot. Day 1, now the anti-metrics. These are the numbers teams love because they're easy. They are also useless. Prompt counts, chat counts, token consumption, number of agents. These measure noise, not outcomes. They also incentivize exactly the wrong behavior. Build more, publish more, celebrate more. Meanwhile, the system decays. A better mental model is this: every KPI maps to an operational lever you can actually tune. Deflection and first contact resolution map to containment design, what the agent must solve versus what it must escalate. If you don't define that boundary, you will either over-escalate and waste time, or overconfidently answer and destroy trust. SLA reduction maps to handoff latency and enrichment. If escalation requires the user to repeat everything, you didn't build an agent. You built a delay. The handoff has to carry the context: intent, urgency, impacted service, device, and what the agent already tried. Grounded accuracy maps to knowledge coverage and retrieval quality. If your content is messy, stale, or too large to retrieve cleanly, the model will improvise. It's not malice, it's math. And adoption maps to user experience: short answers, clear next actions, and fewer decisions per interaction. Paragraphs don't ship work. Decisions do. The next thing leaders miss is ownership. High performance doesn't come from who built the bot. It comes from who owns the outcome. So assign an outcome owner per use case. Not a maker, not a dev lead. An accountable operator. For IT triage, that's usually the service owner or the head of service desk. They sign the KPI targets. They decide what done means. They also own deprecating topics that don't perform. Because if nobody has authority to kill weak behavior, the system accumulates entropy generators forever. Finally, set the system boundary. Pick one domain, one channel, one audience, one backlog. Performance requires a closed system where change is observable. If every department ships an agent to solve a personal annoyance, you don't get a workforce. You get a zoo. And that's the transition point. The roadmap starts by forcing a boundary, because without one, everything becomes theater. The core misconception: automation isn't an agentic workforce. Most leaders have already funded automation. Some of it even worked. A Power Automate flow here, a ticket template there, maybe a chatbot that answers the top 5 questions when the moon is in the right phase. That's not an agentic workforce. That's sparkling automation, isolated wins that look great in a demo because they run in a clean, staged world. But they don't compose into a system. They don't share a vocabulary of intent. They don't have consistent boundaries. They don't learn from failure. And when they break, nobody can explain why. Because they were never instrumented like a system. They were shipped like a feature. The uncomfortable truth is this: Agentic isn't a UI choice, it's an operating model. A real agent behaves less like a chat widget and more like a distributed decision engine. It takes an event, interprets intent, pulls context, selects tools, takes action, verifies the outcome, and then hands off when the risk exceeds its mandate. That loop is the definition, not the chat transcript. And yes, that sounds like a lot. Good, it should. Because what most organizations build first is the opposite. A conversational front end bolted onto existing chaos, with permission sprawl and a vague goal like help users. Helpful isn't a spec, it's how you get confident wrong behavior at scale. So the shift leaders need to make is not task completion, it's outcome completion. Task completion is answer the question, create the ticket. Summarize the policy, it's transactional. Outcome completion is resolve the incident without escalation, reduce time to restore, prevent policy violations. Outcomes have constraints, they have ownership, they have rollback, they have accountability. That distinction matters because once you aim at outcomes, you're forced to design the system that makes outcomes repeatable. And then there's the part nobody wants to hear. System learning doesn't happen because the model is smart. It happens because the platform is instrumented. If you don't capture failure reasons, escalation causes, missing knowledge coverage, tool errors, and routing ambiguity, nothing improves. You don't get an agentic workforce. You get a static bot that slowly becomes wrong as policies drift and services change. Entropy always wins when feedback loops don't exist. This is where the frontier firm framing actually becomes useful if you strip out the hype. Humans lead. They define outcomes, boundaries, and acceptable risk. Agents operate, they execute within those constraints consistently. Systems learn, they improve because the organization measures the right things and updates the design. But only if you do the boring part, the constraints. Most rollouts fail for 3 reasons that are painfully predictable. First, vague goals. Improved productivity means nothing. It produces nothing. It creates competing interpretations and a dozen half-built agents that nobody owns. Second, no constraints. Unlimited tool access turns an agent into a probabilistic admin. People call it innovation. Auditors call it a finding. Third, uncontrolled publishing. When every team can publish an agent to everyone, you don't get empowerment. You get collision. Users don't ask for 50 agents. They ask for one that works. So they try 3, get 2 wrong answers, and decide the whole thing is a toy. Everything clicked for most experienced architects when they realized this. Automation reduces steps. An agentic workforce reduces uncertainty. Automation says, if X, then Y. Agents say, given messy input, what is X and which Y is allowed? That's why the governance and grounding work isn't phase 2. It's foundational. If you skip it, the system doesn't become agentic. It becomes conditional chaos. So the roadmap can't be a feature rollout. It has to be a 30-day operating model that forces clarity. One domain, explicit outcomes, tool boundaries, evidence requirements, and a publishing path that doesn't turn every experiment into production. Because if you don't force that clarity up front, week 2 shows up on schedule, and the platform will do exactly what you configured, not what you intended. The 30-day operating model. A 30-day roadmap fails when it's treated like a project plan. It isn't. It's an operating model that constrains behavior long enough for reality to show up. So the structure is simple. 4 weeks, each with a different purpose, and each with a gate you either pass or you stop. No heroics. No, we'll fix it later. Later is where agent sprawl is born. Week 1 is baseline and constraints. Not building, measuring, and boxing the problem in. You pick one domain and one channel. For this roadmap, IT service is the least controversial place to start because the metrics exist, the workflow is repetitive, and the political blast radius is manageable. Then you establish the baseline. Ticket volume, categories, current deflection, SLA, escalation rate, and the top intent patterns that show up in real user language. You also define the containment boundary on day 1, what the agent must solve, what it must never attempt, and what triggers escalation. That boundary becomes the contract. Week 2 is build and ground. This is where most teams want to start. They're impatient and they ship a chat box. Don't week 2 means you build the first agent that can do one thing end to end, classify, retrieve, propose, and either resolve or route. And you begin grounding discipline immediately. No source, no answer. If the agent can't cite a policy, a runbook, or a known outage notice, it escalates. This is also where you create your initial evaluation set and start scoring grounded accuracy. Not perfect, measurable. Week 3 is orchestrate and integrate. This is where the system becomes real. Orchestration turns a response into a workflow. You integrate the deterministic steps with Power Automate. Ticket creation, assignment, user notifications, logging, and the handoff payload. You introduce tool boundaries. Read operations are default, write operations are gated. You add the first approval pattern if you're doing anything that changes state. And you begin instrumenting failure reasons so the system can improve without guessing. Week 4 is harden and scale. Hardening doesn't mean polishing the prompt, it means making the behavior survivable. You lock down publishing paths, verify logging, validate access boundaries, and run adversarial tests. Prompt injection, tool misuse, and helpful requests that should trigger escalation. You identify topics with high confusion and kill them. You finalize the lifecycle model, pilot, active, deprecated. And then you prepare the next domain based on what the metrics proved, not what leadership feels. Now, the work selection rule, because you can't do everything in 30 days, you choose processes that are high volume, low variance, and high friction. High volume means the savings show up quickly. Low variance means the intent space is stable enough to route reliably. High friction means people hate doing it and will actually use an agent that removes the pain. Password reset flows, access requests, how do I policy questions, common incident triage, service catalog routing, that class of work. And you define done in a way that prevents theater. Done means three things at once: measurable improvement, auditability, and safe rollback. If you can't roll it back, you didn't build a system. You built a liability. Measurable improvement means the KPIs moved for the slice of work you targeted, not anecdotes, not screenshots. Auditability means you can answer what did the agent decide, what sources did it use, what tool did it call, and what outcome occurred. If you can't reconstruct the decision, you can't defend it. Safe rollback means you can disable the agent or remove tool access without breaking the underlying process. That distinction matters because humans still need to work when the model misbehaves. Now, the governance move that prevents parallel chaos. Single intake, single backlog, single cadence. Every agent request goes through one intake path, one queue, one set of prioritization rules. Not because bureaucracy is fun, but because parallel agent building creates incompatible vocabularies and duplicated toolchains. That turns into conditional chaos faster than any threat actor. Cadence is also non-negotiable. A daily build loop for shipping small changes, a weekly governance review for permissions and publishing, and an end-of-week KPI check. If the metrics don't move, you don't scale, you fix. And that's the punchline of the operating model. The platform moves fast, but your organization must move deliberately, otherwise the system will drift, and it will drift away from your intent. Choose the first use case, IT ticket triage, as the entry pillar. If leadership wants a 30-day win that survives contact with reality, IT ticket triage is the entry pillar. Not because IT is special, but because IT has three things most departments don't: volume, instrumentation, and consequences. Tickets already have timestamps, categories, owners, and escalation paths. That means performance is observable, and when the system gets something wrong, the impact is obvious enough to fix quickly. It also wins politically. HR, finance, and legal are high-risk domains with high sensitivity and low tolerance for probabilistic behavior. IT service is still risky, but it's socially acceptable to iterate. People already expect a service desk to ask clarifying questions. They don't expect the payroll agent to take a guess. So the use case is not build an IT chatbot. The use case is ticket triage as a controlled decision pipeline. Classify the issue, enrich the context, attempt a resolution when it's safe, and otherwise route to the correct queue with enough context that the human doesn't start from zero. Here's the flow in plain terms. A user shows up with free text pane, Teams message, portal form, email. Pick one channel first. The agent's first job is intent classification. Not sentiment, not personality. What is this in operational terms? Password reset, VPN, Outlook, device compliance, access request, known outage. Something is broken with no signal. That classification determines everything downstream. Then comes enrichment. This is the part most teams skip because it's not shiny. The agent needs just enough context to stop wasting human time. Who the user is, what device they're on, what service they're touching, whether there's a current incident, and whether this is a repeat. If the organization has an ITSM platform, that's where the prior history lives. If the organization has a service catalog, that's where routing should land. If none of that exists, the agent doesn't magically create it. It just makes the absence visible. After enrichment, the agent makes the only decision that matters: resolve, route, or create. Resolve means the agent has a deterministic fixed path and the risk is low. Reset a password through an approved workflow. Provide a step-by-step runbook with citations. Confirm the user did it. Verify success. Close the loop. Route means the agent can't safely execute, but it can identify the right team and hand them a clean payload. The intent, the likely service, the urgency, the impact, the evidence, and what was attempted. Routing without payload is theater. Payload is where SLA actually improves. Create means the user insists on escalation, or the process requires a record, or the system detects risk. The agent creates the ticket with structured fields, not a copy-paste of the conversation. This is where Power Automate earns its keep. Create, assign, notify, and log. Deterministic steps stay deterministic. Now define the containment boundary up front. The agent must have a contract that says these are the things it is allowed to solve end to end, and these are the things it must never attempt. Never includes anything privileged, anything financially material, anything that changes access without approval, and anything that lacks an authoritative source. That boundary is not about limiting the agent, it's about protecting trust. And this is where the no source, no answer policy starts. Not in week 3, not after the first incident, on day 1. If the agent can't cite a runbook, a policy, a known issue, or a service status update, it doesn't answer. It escalates. The first time an agent gives a confident wrong answer to a user who's already frustrated, adoption dies, quietly, permanently. So for ticket triage, citations and evidence aren't academic. They're how the system earns the right to exist, tied directly to the KPIs you set earlier. Deflection comes from resolving the low-risk, high-volume intents inside the boundary. First contact resolution comes from clean enrichment plus grounded runbooks. Fewer escalations come from correct routing and fewer dead-end handoffs. SLA improvement comes from structured tickets and reduced back and forth. And the best part is you can measure all of it without inventing new telemetry. The ITSM system already tracks timestamps and assignments. You just need to tag agent touched and capture escalation reasons. The transition to the next section is the uncomfortable constraint that makes triage work. Topics aren't free. Every helpful new intent you add creates ambiguity. Every ambiguous route creates mistriage. And mistriage is just escalation with extra steps. So if you want ticket triage to become a pillar instead of a pilot, you have to treat intent like a design asset, not a brainstorm list. Copilot Studio design law, intent first, topic second. Copilot Studio encourages people to think in topics because topics are visible. They feel like progress. Click, name it, write a few trigger phrases, ship it. That's how topic sprawl happens. And topic sprawl isn't just messy, it's an entropy generator. Every new topic adds another overlapping route the system can take, which increases ambiguity, which increases misclassification, which increases escalations, which makes everyone conclude the agent doesn't work. It does work. You just turned routing into a probabilistic game. So the design law is blunt. Intent first, topic second. Intent is the operational meaning behind the user's words. It's stable. Reset my password will still exist next quarter. Can't get into my account still maps to the same underlying outcome. Intent is what you can instrument and improve. Topics are just routing tables. They are implementation detail. That distinction matters because most organizations start by collecting departmental wish lists. We need a topic for VPN. We need a topic for printers. We need a topic for Teams. And then they create 100 topics that all trigger on the word can't, help, or not working. You didn't build coverage, you built collisions. So the first rule is to cap the initial intent space, 10 to 15 intents. Not because the rest don't exist, but because you need stability before you need coverage. In the first 30 days, you're proving that the system can classify and contain reliably, not that it can answer every question in the organization. Here's what those first intents look like in IT triage. Password and account access, VPN or remote access, email and calendar, Teams calling and meetings, device compliance, Wi-Fi, software install, access request, service outage check, and unknown issue as a controlled catch-all. That's enough volume to matter and enough clarity to tune. Now, how do you design intents without guessing? You use intent signals. And Copilot Studio gives you more signals than people use. The obvious signal is user language patterns, the phrases and synonyms people actually type. Not what IT calls it, what users call it. So my laptop won't connect is not 802.1x supplicant failure. You model the human input, then translate. The next signal is metadata. If you have a portal form, it might include service or category fields. If you have ITSM integration, you might have existing categories you can map to. These can reduce ambiguity, but only if your categories aren't garbage. If your ITSM taxonomy is 15 variations of other, the agent can't salvage it. Then there's channel context. A Teams message at 9 a.m. Monday is often, I'm stuck right now. A portal submission might be more structured. An email to a shared mailbox is often a dump of symptoms. Channel changes language. That means channel is part of intent detection, not just where you publish. Now, the part most people avoid, the fallback strategy. In Copilot Studio, fallback is not a safety net. It is a control surface. If you let fallback behave like, I'll try to be helpful anyway, you just build hallucinations into your routing layer. The agent will invent an intent, pick a tool, and act with confidence. So you need one controlled fallback. 1. Fallback should do 3 things. In order, ask one clarifying question to force disambiguation, check for known outage or incident context, and then escalate with a structured payload if it still can't classify. No long conversations, no 20 questions. If the agent can't classify after one clarifier, it routes. That keeps the system fast and keeps the failure mode predictable. And yes, it feels strict. Good. Strict is how you prevent conditional chaos. Now, topic lifecycle. This is the part that prevents your backlog from becoming a museum. You kill weak topics early, not later. Early. Set deprecation criteria up front. Low usage, high confusion, low containment, high escalation, high unknown fallback rate, or repeated misroutes into the wrong queues. If a topic can't hit containment and routing accuracy targets inside 2 weeks, it doesn't get a third month. It gets removed or merged, because every weak topic you keep becomes permanent ambiguity, and ambiguity compounds. Finally, close the loop with a design choice that prevents ghost agents and sprawl later. Treat intents as a shared enterprise asset, not as per agent inventions. One intent registry, one naming scheme, one owner, one backlog. Agents can vary by channel and audience. Intents shouldn't. When intents are stable, topics become small and boring. That's the point. Orchestration becomes the real product. Event to decision to action to verification to handoff. Topics just tell the system where to start. And that transition matters because once routing is disciplined, you can finally build the thing people think they're buying. A control plane. Orchestration is a control plane. Once intents are disciplined, the next mistake is thinking the work is done. It isn't. Routing is just a switchboard. The real product is orchestration. Orchestration is the control plane that turns an interaction into a verified outcome. Event to reasoning to action to verification to handoff. Without that loop, you have a conversational index. With it, you have something that can actually replace work. That distinction matters because most early agents behave like this. The user types a problem, the agent answers in paragraphs, and then the user still has to do the next 5 steps. They copy text into a ticket. They hunt for the right form. They message the wrong team. They repeat themselves. The agent helped, but nothing moved. A control plane agent doesn't aim to be eloquent. It aims to be operational. So the orchestration pattern is simple and repeatable. First, classify. Confirm the intent and the containment boundary. If the user asks for something outside the boundary, the agent doesn't negotiate. It routes. That prevents the slow drift from helpful assistant into probabilistic operator. Second, retrieve. Pull the minimum authoritative knowledge needed to propose a solution. That can be a runbook, a policy, a service status item, or a known issue record. No source means no answer. This is where the agent proves it's not improvising. Third, propose. The agent gives a short, actionable recommendation, not an essay, 2 or 3 steps max, written like instructions. And here's the weird part. The proposal is not the action. It's a plan the system can verify. Fourth, confirm. This is where human in the loop becomes precise instead of performative. You don't approve the whole agent either. You approve decision points. Should I reset your password? Should I create a ticket in this category? Should I request access on your behalf? The approval happens at the boundary between read and write. Fifth, execute, only after confirmation and only through allowed tools. This is where Power Automate and MCP-style tool boundaries matter. The agent should not be composing ad hoc API calls like a drunk junior developer. It should call known tools with known parameters. Sixth, verify. The agent checks whether the action worked. Did the password reset succeed? Did the ticket get created? Did the user confirm access is restored? Verification is where agents stop being theater and start being reliable. Seventh, handoff. If the agent can't resolve, it escalates with a structured payload. Intent, enriched context, sources used, steps attempted, and what it needs the human to decide. The human shouldn't read a transcript, they should read a case file. That's orchestration. Now the uncomfortable constraint, tool invocation boundaries. Every tool you connect is an entropy generator if you don't gate it. Start read-only, list, get, search, delay, create, update, delete. If you allow write operations on day 1, you're not accelerating delivery, you're creating an incident with better marketing. So implement a 2-tier tool policy. Tier 1 tools are read-only and safe. Check service status, search the knowledge base, look up ticket history, fetch device compliance state. These tools reduce uncertainty. They don't change state. Tier 2 tools are write actions and risky. Create a ticket, update a user attribute, grant access, reset credentials, trigger changes in downstream systems. These tools require explicit approval and stronger logging. Some require stronger authentication. The point is not to slow down. The point is to keep autonomy proportional to risk. Human in the loop also needs to be placed correctly. Approve everything is just a slow agent. Approve nothing is how you end up explaining to leadership why an LLM updated a production record. The control plane placement is approve at irreversible boundaries, right actions, privileged operations, external communications, anything financially material, anything that could become an audit question. Everything else should run. And here's why this improves adoption. Users don't want explanations. They want next actions. A good orchestration response looks like, I can do A or B. Here's what I found. Pick one. That turns chat into decisions. Decisions turn into outcomes. Outcomes are what executives fund. So by the end of this section, the system is no longer an agent that talks. It's a control plane that routes, acts, and verifies. But orchestration has a hidden dependency, and this is where most builds stall. Context enrichment. Because reasoning without context is just confident guessing. Context enrichment without overreach. Context enrichment is where most smart agents quietly become privacy incidents. Because enrichment feels harmless. Pull a little identity, a little device info, maybe some recent tickets, maybe a list of installed apps. What could go wrong? Overreach goes wrong. And it goes wrong in two ways at the same time. You increase risk and you decrease accuracy. The model gets more tokens, more noise, more chance to anchor on irrelevant detail. You traded clarity for context hoarding. So the rule is minimum viable context. Only the facts the process needs to make the next decision safely. For IT triage, that minimum set is boring, and that's why it works. First, user identity. Not a biography. Just the stable identifiers that matter for routing and policy. User principal name, department if it maps to support groups, location if it maps to service availability, and whether the user is privileged. Privileged users change the containment boundary. An agent can't treat a help desk admin like an intern with a locked-out mailbox. Second, device state. If the use case touches endpoint compliance, you need device ID, OS management state, and compliance status. You don't need a full inventory dump. The question is simple. Can this user do the thing they're asking for on the device they're using? Third, service context. Is there an active incident? Is the service degraded? Is there a change window in progress? This one is the hidden time saver. Half of my Teams is broken isn't a user problem. It's an outage. If the agent can detect that early, it stops the endless troubleshooting theater and routes to the right message. Status, expectation, and next check. Fourth, recent history, recent tickets, recent similar incidents, recent failed attempts. This is how you avoid retriaging the same person every week. But keep it tight. Last 5 tickets, last 7 days, same category. Anything beyond that becomes narrative, not signal. Fifth, service catalog mapping. If your ITSM has a catalog, pull the service and the default assignment group. That turns I need help into this belongs to group X with fields Y populated, which is what actually reduces SLA. Now the sources, people say M365 signals like that's one thing. It isn't. It's a pile of systems with different governance, different data boundaries, and different failure modes. Enrichment sources you can justify in an IT triage workflow are usually Entra directory attributes, device compliance signals from endpoint management, ITSM fields, and ticket history, and a curated service status source. In some orgs, that service status is in service now. In others, it's in a Teams channel post nobody owns. Either way, make it a source the agent can cite, not a rumor it repeats. And this is where the system law shows up again. Normalize inputs. If your taxonomy for service has 15 spellings of the same thing, enrichment will amplify the mess. The agent can only be as deterministic as the labels you feed it. So define a small taxonomy for the pilot: service, urgency, impact, environment. Not 50 fields, 4. And make the mapping explicit. If the user says Outlook, the system maps to Exchange Online, not emailish problem. Then add a verification step before any right action. This is the difference between enrichment and hallucination. The agent should play back the enriched facts and ask for confirmation when those facts will change behavior. You're on device X, it's non-compliant, and this request requires compliance. Is that correct? You're requesting access to system Y, which is a privileged app. Confirm. Verification doesn't mean you approve everything. It means the agent doesn't treat guest context as truth. Now, privacy. If you're tempted to pull HR attributes, manager chains, performance data, or everything in graph because it's available, stop. That's not enrichment. That's surveillance cosplay. The minimum viable context principle protects you because it forces a justification. What decision does this field influence? If the answer is none, the field doesn't belong in the agent. And yes, more context sometimes improves accuracy, but accuracy without boundary becomes a liability. The agent will learn to use data it shouldn't, and users will learn they can prompt it into revealing it. So keep enrichment tightly scoped, audited, and reversible. If a field becomes risky, remove it and the system still functions, because context is the hidden engine of orchestration. But the next failure mode is what happens when the agent has context, has a plan, and still answers wrong with confidence. That's grounding, and it kills adoption faster than any outage ever will. The failure mode that kills adoption: confident wrong answer. If you remember one thing about adoption, make it this: users will forgive "I don't know." They will not forgive "I'm sure," followed by being wrong. That's the failure mode that kills an agent program in week 2, because the first time an agent answers confidently and incorrectly, the user doesn't file a bug report. They don't politely provide feedback. They screenshot it, paste it into a Teams chat, and the story becomes Copilot makes stuff up. And once that narrative exists, every future success gets dismissed as luck. This is why grounding isn't an enhancement. It's a survival requirement. Grounding failures usually happen for 3 reasons. First, the agent answers from its general model knowledge instead of your enterprise truth. That's fine when the question is generic, and catastrophic when the question is policy, HR, security, or internal process. The model can sound correct while being wrong in exactly the ways that matter to auditors. Second, the agent retrieves the wrong document, not because retrieval is broken, but because your content is ambiguous. 2 similar policies: a stale runbook, a SharePoint page with 3 unrelated procedures jammed into one. Retrieval doesn't fix entropy, it indexes it. Third, The agent blends sources. It pulls one chunk from one doc, another chunk from another doc, and then stitches a reasonable answer that never existed. It feels helpful. It also becomes impossible to defend. So the control rule has to be explicit and enforced. Citations required for any non-trivial claim. Not citations are nice, required. If the user asks, "What's the VPN setup?" the agent can cite. If the user asks, "Can I access this customer dataset from my personal device?" the agent cites or escalates. If the agent can't produce a source, it doesn't answer, it routes. This is also where you separate knowledge from action. Answering and doing are different risk classes, and the platform won't keep them separate unless you design it that way. A grounded answer is read behavior. It's retrieval plus summarization with evidence. An action is write behavior. It's changing state in a system of record. You don't grant permissions because the agent wrote a persuasive paragraph. You grant permissions because a tool call executed under a constrained identity with explicit approval and a log you can defend. That distinction matters because many teams accidentally couple them. The agent answers, therefore it acts. That's how you end up with tool misuse driven by conversational confidence. Now define grounded accuracy because vague quality discussions turn into feelings. Grounded accuracy means, in a test set of real questions, the agent's answer is supported by the cited source, and the source is the correct source for that question. Not close, not sounds right, supported and correct. You measure it with sampling. You don't need a PhD evaluation framework to start. You need a fixed question set, the top intents, the top policies, the top runbooks, and the top known issue questions. You run them weekly, you score correct with correct citation, correct with wrong citation, incorrect with citation, incorrect with no citation, and escalate it appropriately. Your target in 30 days is greater than 85% grounded accuracy on that evaluation set. That's realistic if you constrain scope and enforce no source, no answer. And you categorize failure reasons because fixing the wrong thing wastes weeks. Missing doc, the knowledge doesn't exist in an indexable form. Wrong doc, retrieval pulled an adjacent policy, often because metadata is weak. Wrong inference, the agent made a leap the doc didn't support. Stale doc, the truth changed, the index didn't. Now the part everyone avoids until it hurts, red teaming prompts. Do it early. Not because you expect a nation-state attacker in week 1, but because normal users accidentally behave like attackers. They paste emails, they paste error messages, they paste internal links, and sometimes they paste instructions that conflict with policy. The model will try to comply. So your red team set includes prompt injection attempts, requests to ignore policy, requests to reveal sensitive data, and instructions to perform actions outside the containment boundary. You run them against the agent before you expand the pilot group. And the key is you don't treat failures as the model is dumb. You treat them as design signals, tighten boundaries, improve retrieval, add an escalation clause, remove an unsafe tool, because trust doesn't come from charm, it comes from predictable behavior. And grounding is what makes behavior predictable. But grounding can't be implemented as vibes and prompt warnings. It needs a computable knowledge layer and a retrieval strategy you can tune. SharePoint sprawl won't save you. That's why the next section is Azure AI Search. Turning knowledge into something the system can actually retrieve on purpose. Azure AI Search, make knowledge computable. SharePoint is not a knowledge strategy. It's a document landfill with a search box. And yes, Microsoft Search has improved. Copilot can sometimes find the right page, but sometimes is exactly the problem. An agentic workforce can't run on probabilistic discovery when the output needs to be auditable, repeatable, and fast. The system needs knowledge it can retrieve on purpose. That's what Azure AI Search actually does. It doesn't make content smarter. It makes content computable, indexed, chunked, tagged, refreshed, and security trimmed so retrieval becomes a designed behavior instead of a hope. That distinction matters because grounding collapses when retrieval is accidental. So the simple version is Azure AI Search turns your messy pile of documents into an index the agent can query with structure. And the structure is the whole game. The first design choice is what you index. Most organizations point at the SharePoint site and call it done. That's how you get blended answers and stale policy conflicts. Instead, index the knowledge that is allowed to be operational truth, runbooks, approved SOPs, policy documents, known issue articles, service status notices, and service catalog entries. Not drafts, not personal notes, not the random wiki nobody owns. If it doesn't have an owner and a life cycle, it doesn't belong in an index feeding production answers. Then comes chunking. This is where retrieval either stays clean or becomes a smear. Chunking is splitting documents into smaller pieces so the system can retrieve the exact part that answers the question. If your chunk is too large, the model gets an entire page with 3 procedures and it will blend them. If the chunk is too small, the model loses context and starts inventing transitions. The right answer is boring. Chunk by atomic procedure. 1 policy section per chunk, 1 runbook step sequence per chunk, 1 exception clause per chunk. The goal is not to index the doc. The goal is to index the decision unit. That's the atomic knowledge rule. If a piece of content can't stand alone as an answer source, it's not a good chunk. Next is metadata. Without metadata, retrieval becomes a popularity contest. Metadata is how you turn VPN policy into VPN policy for contractors. Region EU applies to Windows, updated 2025-01-12 owner security ops. The agent doesn't need all of that in the response. It needs it for filtering and ranking so it doesn't retrieve the wrong thing. So tag content by service, audience, region, risk tier, doc type, and last reviewed date. Keep the taxonomy small, consistent, and enforced. If your metadata is optional, it will be missing on the documents that matter most. That's how entropy works. Now, security trimming. This is not a nice to have. If the index can retrieve content the user shouldn't see, you will eventually leak something. Not because the model is malicious, because a user will ask a question that causes retrieval to surface restricted content, and the system will try to be helpful. So the index must respect access controls. Retrieval should only return chunks the requesting user is entitled to read. In other words, your knowledge plane must obey the same boundary rules as your data plane. Refresh cadence is the next trap. A static index becomes wrong, fast policies change, outages resolve, runbooks get updated after incidents. If your index refreshes weekly and your operations change daily, the agent will confidently answer with yesterday's truth. Users will notice. Trust will die. So set refresh cadence by doc type. Service status and known issues refresh frequently. Policies refresh on publish, runbooks refresh on change control, and make last indexed visible in telemetry because stale answers look identical to hallucinations from the user's perspective. Now the output requirement, show sources, not because citations feel academic, because they're the only way to make the system defensible. The agent response should include the answer, the linked source, and the specific section title or excerpt reference. If the system can't provide that, it escalates. No source, no answer. That rule becomes enforceable when retrieval is a designed component. And here's the weird part. Once you implement Azure AI Search, you stop arguing about prompt quality as if it's the product. Prompts become thin glue. Retrieval becomes the product. Copilot Studio can sit on top as the orchestration layer, but Azure AI Search becomes the grounded knowledge backbone. It's how you make policy computable, not just searchable. But retrieval still isn't action. Knowing the right runbook step doesn't execute the step. Knowing which ticket category applies doesn't create the ticket. For that, you need tools that are predictable, governed, and reusable. That's where MCP shows up and why it matters more than most people want to admit. MCP, turning Copilot from chat into a system. Azure AI Search makes knowledge retrievable on purpose. Good. But the next failure mode shows up immediately. The agent still can't do anything predictable with that knowledge. It can explain a runbook, it can cite a policy, and then it stops, waiting for a human to carry the work across the finish line. That's where MCP comes in. Most people hear Model Context Protocol and think it's a developer convenience. It is not. In enterprise terms, MCP is a standard contract for tools, a predictable way for an agent to discover capabilities, call them, and receive structured results. Less bespoke glue, more reusable capability. And that distinction matters because without a standard tool interface, every agent becomes a one-off integration project. One bot talks to ServiceNow through a custom connector, another talks to Jira through a different pattern, a third one hits Graph with a different auth model. Over time, you're not building an agent ecosystem, you're building an integration junkyard. Okay, so basically, MCP makes tools legible to agents. A tool isn't just an API endpoint. A tool becomes name, description, parameters, and expected output. That's what gives the agent the ability to plan and execute in a loop without you hard-coding every branch. It's the difference between a human seeing a labeled button that says create ticket versus a human being handed a raw REST API spec and being told, figure it out. Now, why does that translate into fast ROI? Because MCP shifts effort from building new agents to reusing the same small set of enterprise tools everywhere. Build one good ticket create tool. Reuse it across IT triage, HR requests, access requests, and facilities. Build one service status lookup tool. Reuse it across every support experience. Build one KB retrieval with citations tool. Reuse it everywhere grounded answers matter. That's how you scale without multiplying chaos. But the uncomfortable truth is MCP also accelerates the risk you were already going to have. Because tools are authority. And when you give an agent a tool that can write, you've handed it a lever that moves production systems. So the design law for MCP in the first 30 days is strict. Read operations first. Write operations gated. Read, list, get search tools are where you start. They increase accuracy without changing state. Write tools, create, update, delete, only enter the system when you've already proven routing stability, grounding discipline, and logging. And even then, you gate them behind explicit approvals. This is not a philosophical stance. It's entropy management. Because the fastest way to create an agentic incident is to connect a write-capable tool with no lifecycle, no allow list, and no rollback. And yes, token sprawl becomes real here. API tokens, client secrets, and unmanaged credentials become shadow admin keys the moment they get copied into 3 environments and 10 agents. The organization forgets they exist until one expires, or worse, gets reused somewhere it shouldn't. So MCP governance starts with a tool allow list and a deny list. Allow list means only approved MCP servers and approved tools inside those servers. Deny list means explicitly block classes of tools you know you don't want. Delete operations, bulk updates, privilege grants, anything that changes identity, access, or finance without a human boundary. That's governance by design, not governance after cleanup. Now, how does MCP actually turn chat into a system? Because it creates a closed loop. The agent can reason, call a tool, read the response, validate it, and decide the next step. That loop is what makes an agent definition hold. Runs tools in a loop to achieve a goal. Without tools, the agent is a narrator. With tools, it becomes an operator. But only if the tools are predictable. So you keep tool descriptions short and specific. You don't expose 50 vaguely named operations and hope the model chooses the right one. That is just conditional chaos with better packaging. You expose a small, well-labeled toolset that matches your orchestration steps. Classify, retrieve, check status, create ticket, update ticket, notify user, request approval. And you instrument tool outcomes. Tool errors matter more than model errors because tool errors break workflows. Track which tool failed, why it failed, and what the agent did next. If the agent retries endlessly, you've built an infinite loop that burns budget and trust. Finally, the key design choice that prevents ghost agents later shows up again. Prefer reusable tools over reusable agents. Agents are experiences. Tools are capabilities. When you standardize tools, agents can stay small, domain-scoped, and disposable. When you don't, every agent becomes a fragile snowflake that nobody can maintain. So MCP isn't the cool protocol. It's the enforcement layer that makes tools composable, governable, and repeatable. Now that you have retrieval that's computable and tools that are standardized, you can finally connect the two into a real system. So next, it stops being theoretical. IT ticket triage end-to-end with Copilot Studio routing, Azure AI Search grounding, MCP tools for actions, and Power Automate doing the deterministic work. Demo Architecture 1. IT ticket triage end-to-end. Here's the end-to-end demo architecture that makes executives stop asking, so it's chat? And start asking, when can this hit production? The flow is intentionally boring because boring is how enterprise systems survive. Start with the user's issue, coming in through one channel. Pick Teams or a portal first, don't do all of them. Channel sprawl is just topic sprawl with better UI. The user types free text, VPN died, Outlook won't send, can't access SharePoint, whatever. The first step is intent classification in Copilot Studio. This is where your 10-15 intents actually earn their keep. The agent selects an intent and immediately applies the containment boundary tied to that intent. Then the agent enriches context, not everything. Minimum viable context, user identity, device compliance state if relevant, and service context like known outages. This enrichment should come from predictable sources. Entra attributes, endpoint management signals, and the ITSM ticket history. If the organization doesn't have those sources well defined, the demo still works. It just surfaces the real constraint. Your operations are not computable yet. Now the fork in the road, resolve, root, or create. Resolve means the agent can safely close the loop. This is where the grounded knowledge path triggers. It retrieves a runbook or known issue article and answers with citations. If the fix requires a deterministic step, like triggering a password reset workflow, that step should not be done by reasoning. It should be done by a tool call. In this demo, Power Automate handles that deterministic execution. The agent proposes the action, confirms with the user at the right boundary, then Power Automate executes and logs. Root means the agent can't solve, but it can root cleanly. The output isn't a transcript, it's a payload. Intent, impacted service, urgency, device state, and what was already attempted. That payload becomes a ticket description plus structured fields. The human gets a case file, not a chat log. That's what reduces SLA. The human doesn't retriage. They start where the agent left off. Create means you must open a ticket no matter what. Policy requires it, access requires it, or the user insists. The agent still adds value by making the ticket structured and pre-classified. That's the difference between we deployed Copilot and we reduced backlog. Now where each product fits, Copilot Studio drives the orchestration and routing. Topics are just the front door. The core logic is the decision loop. Classify, enrich, retrieve, propose, confirm, execute, verify, handoff. Power Automate is the system's muscle. It handles the deterministic steps you never want the model inventing. Create ticket, update ticket, assign queue, notify user, write to audit log, post to teams, and trigger approvals. If it's an if this then that action, Power Automate does it. The agent decides when to call it, not how to rewrite it. The ITSM backend, ServiceNow, Jira Service Management, whatever, remains the system of record. That matters. You are not replacing ITSM. You're improving the front-end decision quality and reducing the human time spent on intake, classification, and back and forth. If someone tries to rebuild ITSM with agents, the demo should fail on purpose, because that's how programs die. Now layer in MCP where it's useful. In the demo, MCP provides standardized tools to interact with ITSM and status sources. Read tools first. List open incidents for this user, check service status, retrieve ticket templates, fetch routing groups. Write tools only where you've already defined approval and rollback. Create ticket, update ticket, request access. The point is tool predictability, not novelty. Success criteria are not subjective. Containment rate, how many interactions resolved without ticket creation. That's deflection. Resolution time for the interactions the agent touches. Does cycle time drop? That's SLA impact escalation reduction. Fewer wrong handoffs, fewer ping-pong assignments. That's operational stability. And you instrument it. Every run logs, detected intent, confidence, retrieved sources, tools invoked, execution status, escalation reason, and final outcome. If you can't answer why did it do that, you don't have an agent. You have a magic trick. The best part of this demo is you can run it with a small pilot group in week 2, and you can improve it daily. You'll discover missing knowledge coverage, ambiguous intents, and tool errors immediately. That's not failure. That's the system finally telling the truth. And here's the transition. Once you can triage end to end, the next demo isn't about tickets, it's about trust. Grounded policy answers with evidence or nothing. Demo architecture 2. Grounded policy answers with evidence. This second demo exists for one reason. Policy answers are where hallucinations become career limiting. IT and HR questions feel harmless until an agent confidently tells someone they're allowed to do something they're explicitly not allowed to do, or it cites the wrong clause, or it mixes two versions of the same policy and produces a third policy that never existed. Nobody audits the chat transcript for tone, they audit it for harm. So this demo is built around the highest risk question types: SOPs, runbooks, compliance rules, and internal policy. The stuff people ask in a hurry, copy into emails, and then treat as truth. The architecture is intentionally strict. User asks, can contractors store customer data in OneDrive? Or what's the process for requesting elevated access? Or are we allowed to use personal devices for M365? The agent's first behavior is not to answer, it's to classify the question type and set the response mode. If it's policy or compliance, the agent goes into evidence mode. Retrieve first, cite always, and refuse to speculate. Now the backbone, Azure AI Search as the source of truth, not SharePoint search, not I think I saw a doc. Azure AI Search Index, designed for policy retrieval, chunked by atomic sections, tagged with metadata like policy domain, audience region, and last review date, and security trimmed so the user only retrieves what they're allowed to read. The retrieval step pulls the top chunks that match the question. But the key design constraint is this: the agent can only answer from retrieved content. It can paraphrase, it can compress, it can explain, it cannot invent. That's how you get audit-ready responses. The output format is also strict because format is a control mechanism. The response is short answer, source, next action, escalation path. Short answer means 1 paragraph max. If the agent needs 5 paragraphs, it doesn't understand the policy boundary well enough, or the policy itself is ambiguous. Either way, long answers are where the model starts helping. Source means the exact document and section with a link if your environment allows it. If there are multiple sources, the agent lists them explicitly and calls out the conflict. It does not blend them. Next action means the operational step the user should take. Submit request via this form. Open a ticket in this category, use this approved storage location, or escalate to security ops. Policies without next actions don't reduce work, they create more meetings. Escalation path is the final safety valve. If the question involves exceptions, regulatory jurisdiction, or privileged access, the agent routes. It doesn't negotiate policy exceptions in chat. Now the inevitable reality, policy conflicts. You will have them, every enterprise does. 2 docs disagree, one is newer, one is unofficial, one has the right title but the wrong audience. The system needs a conflict strategy that doesn't rely on trust the model. So the demo includes conflict handling rules. If 2 policies conflict, the agent answers conflict detected, cites both, and escalates to the policy owner. That escalation payload includes the retrieved chunks and the reason the system flagged ambiguity. You don't hide the mess, you surface it. If the doc is outdated, the agent says it's outdated, cites the last reviewed date, and escalates. Stale truth is not truth. And if the index doesn't contain the answer, the agent refuses. No source, no answer. The refusal is not, I'm sorry. It's operational. I can't find an approved source. I can open a ticket to the policy owner and include your question. Now measuring accuracy, because this is where most teams lie to themselves. You build an evaluator set, a fixed list of real policy questions that matter. Then you score failures with a taxonomy, missing doc, wrong inference, stale doc, or conflict. That taxonomy matters because each failure has a different fix. Missing doc is content work, wrong doc is metadata or chunking, wrong inference is response constraints, stale doc is lifecycle governance. And the demo closes with the proof point your stakeholders actually care about. You can show the evidence trail. Every answer has citations, every escalation has a reason, every I don't know becomes a backlog item to improve knowledge coverage. That's the difference between Copilot answered a question and the organization can trust what it answered. Demo Architecture 3. Approvals via Teams adaptive cards. This third demo is where the agentic workforce stops sounding like marketing and starts looking like a control system, because approvals are the moment an agent either earns trust or becomes a liability. Most organizations try to handle risk with a generic human-in-the-loop rule. Someone should approve it. That's not control, that's delay. A real enterprise pattern is tighter. The agent runs everything it can deterministically, then it pauses only at decision boundaries that are irreversible, privileged, or audit relevant. That boundary becomes visible through adaptive cards in Teams. And yes, Teams is the right place for this, not because it's trendy, but because it's where approvals already happen in the real world. Managers, service owners, security reviewers. They don't want to read paragraphs. They want to click a decision and move on. So the demo flow starts with detection. The user asks for something that crosses a risk threshold. Grant access to this SharePoint site. Approve an exception. Reset MFA for a user. Create a mailbox delegation. Approve a spend request. Approve a change. It doesn't matter which domain you pick. What matters is the shape of the workflow. Request, validate, approve, execute, log. Step 1. The agent classifies the intent and evaluates risk. This is not a vibe check, it's a rules check. If the intent maps to a right action or touches sensitive data or changes permissions, the agent flips into approval mode. It gathers the minimum context required to make the decision reviewable. Who is requesting? What resource is being changed? Why? For how long? And what policy applies? And it retrieves the relevant policy source, because approvals without policy context just become whoever clicks first wins. Step 2. The agent generates the approval payload. This is a structured object, not a narrative. Requester, target resource, requested action, scope, duration, justification, evidence link, and the downstream action that will execute if approved. The agent also includes a deny reason required field. Denials without reasons create shadow workflows. People just resubmit until someone approves. Entropy wins. Step 3. Teams adaptive card is posted to the approver. The card format matters. It should be short enough that the approver can decide in 10 seconds, but complete enough that they don't need a follow-up meeting. So the card contains the action summary in one line, the justification in one sentence, the policy citation as a link, and 3 buttons. Approve, deny, and request more info. That third button is not politeness. It is how you prevent deny from becoming the default because the approver lacked context. Now the important part, the card is not just a UI, it is the enforcement mechanism, because clicking approve triggers a deterministic workflow that is version controlled and logged. This is where Power Automate does the heavy lifting. It captures the approval decision, stamps who approved, when they approved, the exact payload they approved, and then executes the right action through the approved toolpath. No ad hoc calls, no agent decided to improvise. If the approval is denied, the workflow logs the reason and routes it back to the requester with the next step, what to change, who to contact, or what policy blocked it. That reduces rework and stops the agent from becoming a dead end. If the approver requests more info, the agent re-engages the requester with one targeted question, updates the payload, and reissues the card. No long chat, just fill the missing field and continue. Now the guardrails. You need a risk threshold model, not complex. 3 tiers. Low risk. Read-only actions, status checks, knowledge retrieval, no approvals. Medium risk, write actions that are reversible and low impact, like creating a ticket or updating a non-sensitive field. Optional approvals, high risk, access changes, privilege changes, financial actions, external communication, or anything that changes identity. Mandatory approvals, and you enforce this in orchestration, not in documentation. The operational effect is immediate. Cycle time drops because the agent does the prep work and routes the decision to the correct human with the right context. Risk drops because right actions only execute after an explicit, logged decision. And adoption rises because users see outcomes, not chat. This demo also closes an early open loop. The design choice that prevents ghost agents later is the same choice that makes approvals work. Put decision boundaries in the system, not in the slide deck. Agent sprawl is predictable. Design for it up front. Agent sprawl isn't a later problem. It's the default outcome of giving people a new capability with no enforced boundary. Most organizations think the risk is too few agents. The real risk is too many, because users don't want 50 agents. They want 5 that work, every time in the same places they already work. When the ecosystem turns into a catalog nobody understands, adoption doesn't fail loudly. It just decays. People go back to emailing the service desk and forwarding PDFs because it's faster than deciding which agent might be correct. And sprawl creates a second, quieter problem: ghost agents. Ghost agents are agents that nobody uses, nobody owns, and nobody remembers, but they still exist, still connect to knowledge, still have tool permissions, and still generate audit surface. They're the perfect entropy generators, invisible most days, catastrophic on the wrong day. So if leadership wants scale without liability, the program has to treat sprawl as inevitable and design for it upfront. Start with the uncomfortable truth: self-service agent creation is not democratization. It is distributed risk creation. And the platform will happily allow it because platforms optimize for capability, not for your audit findings. That distinction matters. So the first control is a catalog discipline that feels boring and saves the program. Every agent needs a name that describes an outcome, an owner that signs the outcome, a business sponsor that signs the risk, and a lifecycle state that reflects reality. Pilot, active, deprecated, retired. Not V1 and V2 and test final. Lifecycle state isn't a label, it's a policy trigger. Pilot agents can't publish broadly. Deprecated agents can't receive new users. Retired agents lose tool access and knowledge bindings. If those transitions don't remove capability, they aren't lifecycle states. They're stickers. Next, adopt a reuse strategy that prevents the agent for everything pattern. The right reuse unit isn't the agent, it's the tool. Agents are experiences, tools are capabilities. If the organization standardizes tools, ticket creation, status checks, identity lookup, KB retrieval, teams can build small, scoped agents without reinventing integrations. If the organization tries to standardize agents, it builds brittle monoliths that nobody trusts and everybody forks. Forking is how sprawl becomes permanent. So the rule is, prefer reusable MCP endpoints and flows over reusable agents. Build once, reuse everywhere. Then control publishing. This is the simplest governance posture that still allows innovation. You can build, but you can't publish. People can prototype in a constrained environment. They can test with themselves. They can even share inside a small group. But the moment an agent becomes enterprise-facing, it enters a publishing workflow with review gates, data sources, tools, write permissions, grounding strategy, telemetry, and owner assignment. If you don't separate build from publish, you'll never catch sprawl. You'll only discover it when the CEO asks why there are 3 VPN helpers and none of them agree. Now define the retirement policy before you need it. This is where programs usually lie to themselves. We'll clean it up later. They won't. Retirement needs automatic triggers, low usage over a time window, high escalation rates, repeated incorrect routing, missing owner, missing sponsor, or tool access that no longer matches the approved pattern. When a trigger hits, the owner gets a review task: improve, merge, or retire. And retirement must be real. Remove it from discovery, revoke tool permissions, archive logs, and keep the audit record. And if you only hide the agent but leave the permissions, you didn't retire it. You just made it harder to notice. Finally, the design choice that prevents topic sprawl from turning into agent sprawl: treat intents as an enterprise registry. One intent taxonomy shared across agents. If each team invents its own intent set, the ecosystem fragments immediately. Password reset becomes account unlock, becomes login problem, becomes access issue, and now routing quality collapses across every agent. The user doesn't care which team built it. They care that the system behaves consistently. So make intent a shared asset, make tools reusable, and make publishing gated. That's how you get scale without panic. Because the platform will not stop you from creating entropy. You have to Entra Agent ID, identity for non-humans. Once agent sprawl becomes visible, most organizations reach for governance as paperwork, a spreadsheet, a review meeting, a naming convention, and a promise to be careful. That is not governance. That's documentation of drift. The only governance that holds in an enterprise is enforced identity, because identity is the anchor point for permissions, conditional access, audit trails, and incident response. Without it, your agent ecosystem is just anonymous toolchains acting on real systems. So Entra Agent ID matters for one blunt reason: agents become actors. Actors need identities. In Entra terms, an agent identity is the non-human principle that represents the agent when it touches data or invokes tools. It's the thing that answers the question auditors always ask, and your teams always struggle to answer: who did what, when, using what permissions, and under which policy controls. If the answer is the agent did it, you don't have an answer, you have a story. Entra Agent ID turns that story into a record. Now, here's the part most organizations miss. Agent ID isn't about whether a user can chat with the agent. That's surface access. Agent ID is about what the agent can do once it's engaged, what data it can read, what systems it can call, and what actions it can execute. That distinction matters because most early rollouts overfocus on user access lists and underfocus on agent capability boundaries. Over time, user access stays roughly stable. Agent capabilities always expand. They expand because someone adds just one more connector, just one more tool, just one more write action, and those exceptions accumulate. Entropy always wins through exceptions. So the first architectural law for Agent ID is least privilege by default, not least privilege for users. Least privilege for the agent as an actor. That means the agent identity gets only the permissions needed for its defined outcome in its defined scope, in its defined environment. If the agent triages issues, it does not need permissions to create accounts. If it answers policy questions, it does not need permissions to grant access. If it can read device compliance state, it does not need the ability to update device configuration. Read and write must stay separate identities, or at least separate permission sets, because write permissions are how experiments become incidents. Next, conditional access becomes your control surface. Most people treat conditional access as user security. In architectural terms, conditional access is an execution policy layer for identities. If the agent identity exists, you can constrain when and where that identity can be used. Restrict to compliant devices, restrict to trusted locations, restrict session behavior, and block high-risk sign-in conditions. This is how you stop toolchains from becoming shadow admins. And you don't wait until after the first scary incident. You design the baseline policy the same way you design the agent. Start restrictive, then loosen with evidence. Now, the thing leadership actually cares about isn't the identity object, it's the audit anchor. Agent ID gives you a stable principle that shows up in logs across the stack. Entra sign-in activity where applicable, Power Platform activity, tool invocation, approvals, ticket creation, and downstream system changes. When something goes wrong, you can trace the chain. Without that, you're debugging a ghost. And this is where the escalation model becomes real. Privileged actions require stronger boundaries than normal actions. So your orchestration needs a privileged tier model. Standard actions run under the base agent identity. Privileged actions either require step-up authentication, explicit approvals, or a separate privileged agent identity that can only be used through an approval workflow. You don't let the same agent casually move from reading a runbook to changing access controls. That's not autonomy. That's uncontrolled privilege drift. Finally, Agent ID is how you make ownership enforceable. Earlier, the system required every agent to have an owner and a sponsor. Agent ID ties that to an identity lifecycle. When the owner changes roles, the sponsor changes, or the agent gets deprecated, you can change access, rotate secrets, revoke permissions, and retire the identity. That's what stops ghost agents from retaining power after everyone forgot they exist. So the simple version is Entra Agent ID makes agents accountable. And in enterprise systems, accountability is the only thing that scales. Because as soon as non-humans can act, you're no longer managing chatbots, you're managing identities with tools. Governance that doesn't kill innovation. Most leaders hear governance and picture a committee that meets monthly to approve nothing. That's not governance. That's delay disguised as control. Real governance is a design constraint that lets building happen fast while keeping the blast radius small. So the program starts with a posture that feels restrictive but actually accelerates delivery. Retrieval only first, then controlled write operations. Retrieval only agents are where innovation should be cheap. They read approved knowledge, cite sources, and escalate when they can't. That gives you immediate deflection and reduces human workload without risking state changes in downstream systems. And it trains your organization on how to build with discipline, content ownership, metadata, evaluation sets, and no source, no answer. If you can't govern retrieval, you have no business governing actions. Then you introduce write operations as a gated capability, not a default feature. Create ticket, update ticket, trigger an approval, send a templated email. These are controlled actions with audit logs and rollbacks. Anything beyond that, privilege changes, access grants, deletions, lives behind higher gates or separate identities. Autonomy expands only when observability proves it's safe. Now, the scaling mechanism is environment strategy. Not because Power Platform needs more environments for fun, but because environments are your safety lanes. You need 3 lanes and they are not optional. Lane 1 is personal productivity. This is where experimentation lives. People can build, test, and learn. They can't publish broadly. Tool access is minimal. Knowledge access is constrained. The purpose is skill building without enterprise liability. Lane 2 is departmental. This is where teams solve real workflow problems with a bounded audience. Publishing is limited to the department or group. Tool access expands, but only to approved connectors and MCP tools. This is where you prove adoption without creating global sprawl. Lane 3 is business critical. This is production, ALM exists, dev, test, prod separation exists, owners exist, sponsors exist, audit logging is on, tool allow lists are enforced. And if an agent touches sensitive data or performs right actions, it passes review gates before anyone outside the build team can use it. That lane structure is how you scale without turning every cool idea into enterprise risk. Now for the part that makes or breaks governance, data boundary enforcement. DLP and connector policies aren't paperwork. They're the only thing standing between useful automation and accidental data exfiltration. If a builder can casually connect an agent to a personal mailbox, a consumer storage service, and a high-trust internal system in the same flow, you didn't build an agent platform. You built a leakage machine, so you define connector boundaries by lane. In personal productivity, block outbound and high-risk connectors. In departmental, allow a curated set. In business critical, allow what's needed, but only through approved tool surfaces with identities you can audit. Cross-boundary data movement becomes a design decision, not a maker decision. Human in the loop also needs to be used correctly here. The governance mistake is to force approvals everywhere. That's how you kill adoption. The correct placement is still the same. Decision boundaries with risk. Approvals for right actions above a threshold. Approvals for privilege. Approvals for external communications. Everything else runs. And this is the principle that stops chaos without stopping builders. You can build, but you can't publish. That posture sounds cynical. It is. It's also true. Builders don't need permission to explore. They need a path to graduate their work into production without bypassing controls. So the governance model gives them a clear graduation path. Prove routing stability, prove grounded accuracy, prove tool discipline, prove logging, assign an owner, then publish. The gates are explicit and the gates are fast. If you hide the gates behind meetings, people route around them. If you enforce the gates in design, people ship safely. Governance that doesn't kill innovation is simple. Constrain where agents can act, constrain what they can touch, and make publishing the only real checkpoint. Then the system can scale, because control that depends on memory always erodes. Control that depends on design holds. Observability, the flight recorder problem. Governance without observability is just optimism with a meeting invite. Most organizations can describe what they intended an agent to do. They cannot describe what it actually did. Not reliably, not at scale, not after the first incident review when legal asks for the exact sequence of actions. This is the flight recorder problem. In aviation, nobody debates whether they need logs after a crash. In enterprise AI, teams still treat logs like a premium feature. Nice later, not required now. That's how you end up with agents that can act but can't be explained. And an agent that can't be explained is an agent you can't defend. So observability becomes the third pillar of control alongside grounding and identity. It is what makes intent enforceable over time. Start with the minimum, decision logs, not chat transcripts, decision logs. A transcript tells you what the user said. It does not tell you why the agent chose an intent, why it called a tool, why it escalated, or why it refused. You need a record of the agent's decision points, classification result, confidence, retrieved sources, tool calls attempted, tool results, verification outcomes, approvals requested, approvals received, and the final disposition. That means every meaningful step produces a log event you can query, not an export you have to dig up later, a queryable record. And yes, the platform gives you pieces, Power Platform admin views, agent registries, Purview DSPM for AI, and Defender signals. But those surfaces only help if you treat observability as a design requirement, not a retrospective cleanup task. Audit logging is the first non-negotiable. If the agent can access enterprise data or execute actions, its activity must land in audit logs with a stable identity anchor. This is where Entra Agent ID stops being theoretical. It becomes the principle you can search for when you need to know what happened. The next surface is monitoring, not just is it up, but is it behaving? So the metrics that matter are not messages sent. They are operational outcomes, containment rate, how often the interaction ends without a human, escalation rate, how often it punts to a human, and why. Escalation reasons, missing knowledge, out-of-scope request, tool failure, policy restriction, low confidence or user frustration, grounded coverage, which intents have strong sources and which ones are running on vibes. Tool error rate, which tools fail, how often and at what step. Handoff latency, how long it takes from escalation to a ticket created, assigned, and acknowledged. And here's the weird part. Observability is also a content strategy. If your top escalation reason is no source, that isn't a model issue. That's a knowledge gap you can fix. If your top failure is wrong source, that's metadata and chunking. If your top issue is tool failed, that's integration reliability. In other words, telemetry becomes your backlog. Now connect this to real enterprise monitoring surfaces, because this has to live somewhere. Agent registry is your inventory view. What exists, who owns it, what it connects to, and what lifecycle state it's in. If you can't list your agents, you can't govern them. Sprawl always hides in what you don't inventory. Purview DSPM for AI gives you posture signals, where sensitive data shows up in prompts and responses, which agents interact with it, and what risk patterns are emerging. That's how you stop the "we didn't know Copilot could see that" conversation before it turns into an incident. Defender for AI signals give you threat-focused telemetry, injection attempts, anomalous behavior, suspicious tool usage patterns, and abnormal access. Not because your users are attackers, but because your environment will eventually contain attacker-like behavior. Normal usage generates weird inputs. Malicious usage generates targeted ones. Both need detection. But none of those surfaces matter if you don't operationalize them. So the practice is simple: weekly failure review, not a quarterly steering committee. A weekly 30-minute review of the top failures, top escalations, and top incorrect answers. You take the top 5 issues and you adjust one of 3 things: intent routing, knowledge indexing, or tool boundaries. Then you run the evaluation set again. That loop is what turns an agent from a demo into a system. And one more thing, make rollback real. If you publish an agent update and containment collapses, you need a path to revert behavior quickly. Observability tells you it collapsed. Release discipline lets you undo it. Without both, every improvement attempt becomes a production gamble and teams stop shipping. So the law for observability is blunt. If you can't replay the agent's decisions, you don't have control. You have an experiment running in production, and experiments always drift. The good news is this is solvable in 30 days if you treat it as part of the product, not an accessory. Because once you can measure, you can govern. And once you can govern, you can scale without guessing. Now the roadmap stops being conceptual. Next, day-by-day actions, the gates, and the exact work that turns all of this into a working enterprise system. Days 1-10, build the first working system. Days 1 through 10 aren't for vision decks. They're for forcing a working system into existence with constraints tight enough that it can't lie to you. Days 1 and 2, pick the use case, lock the KPI targets, and draw the escalation boundary in ink. You're not selecting AI opportunities. You're selecting one operational flow where deflection and cycle time can move inside 30 days. IT ticket triage wins because it's measurable, high volume, and politically survivable. Then you set targets that can't be gamed. 20 to 40% deflection for the chosen intake channel, 15 to 30% SLA reduction for the subset of tickets the agent touches, and 10 to 25% fewer escalations caused by misrouting. You also define the hard line, what the agent must never do. Anything involving access grants, privilege changes, or policy exceptions escalates by design. No debates later. The agent doesn't try. It routes. Days 3 through 5. Design the intents and topics, then implement the fail-safe behaviors. This is the week where topic sprawl either starts or gets prevented. You create 10 to 15 intents, not departments, not everything users might ask, stable intents that map to a containment boundary. For each intent, you write 3 things: success criteria, allowed actions, and escalation triggers. If you can't express those in one screen of text, the intent is too broad. Then you implement fallback. One fallback. Fallback is not be helpful. Fallback is controlled uncertainty. Ask one clarifying question, then escalate. If your fallback tries to answer anyway, you're building confident wrongness into the core. And you set kill criteria now, not after the pilot embarrasses you. Low usage, high confusion, high escalation rate, low containment. If a topic fails, it gets merged or retired. Dead topics aren't harmless. They create ambiguous routing forever. Days 6 through 8, implement orchestration and enrichment. Connect ITSM with deterministic automation. This is where you build the actual loop. Classify, enrich, retrieve, propose, confirm, execute, verify, handoff. The orchestration lives in Copilot Studio because you need a control plane, not just a chat interface. The enrichment is minimal. Identity, device state, if relevant, recent incidents, and service status. Don't hoard context. Context hoarding becomes privacy risk and retrieval confusion. Then you connect your ITSM system with Power Automate, not because it's pretty, but because it's deterministic. Ticket creation, assignment, notifications, and logging belong in a workflow engine, not in an LLM's improvisation. At this stage, tool discipline matters more than cleverness. Start read only where possible. Check service health, list known incidents, pull user ticket history. If you must write, keep it reversible. Create a ticket, add a note, post an update. Anything privileged waits. Days 9 and 10. Pilot users, create an evaluation set, and baseline containment and accuracy. Pick a small pilot group that represents real usage, not enthusiasts. You want normal people with normal impatience. Give them one clear instruction. Use this for these issues, and if it escalates, that's expected. Now build the evaluation set. This is not test cases. It's a fixed list of the top questions and intents the agent must handle. VPN access, password resets, device compliance questions, known outages, ticket status, and basic how-to procedures. You run the same set every week to see drift, and you measure 3 numbers immediately: containment rate, escalation reasons, and grounded accuracy for anything that produced an answer with a source. If you don't have sources yet, you still measure refusal correctness. Did it escalate when it should? Now the gate to proceed. You do not advance to days 11 through 20 because the team feels good. You advance because the system meets 3 conditions: measurable lift against the baseline, no access violations, and logging turned on with traceable outcomes. Lift means The pilot produced a real reduction in human touches for the selected intents, even if it's small. No access violations means the agent didn't retrieve restricted content or execute actions outside boundary. Logging means you can explain every escalation and every tool call. If you can't pass that gate in 10 days, the program doesn't need more features. It needs tighter scope, because the first 10 days are about proving the system boundary holds. Once it does, you're allowed to solve the next problem, trust at scale. And trust only comes from grounding plus tool discipline, enforced relentlessly. Days 11 to 20 ground, stabilize, and reduce entropy. Days 11 through 20 are where most programs either become a system or become a clever demo that everyone quietly stops using. Week 2 proved you can root and contain within a boundary. Now you have to make the answers defensible, the tools predictable, and the failure modes measurable. This is the phase where entropy shows up as small exceptions. And small exceptions are how agent programs die. Days 11 through 13, build the Azure AI Search index and make the chunking strategy non-negotiable. You're not connecting SharePoint, you're building an operational knowledge index. So you start by choosing what qualifies as truth. Approved runbooks, SOPs, known issue articles, and policies with owners. If it's a draft, it doesn't go in. If it's ownerless, it doesn't go in. If it changes without change control, it doesn't go in. Then chunking, don't overthink it. The unit of retrieval is the decision unit. One procedure, one exception clause, one policy section. If your chunk contains multiple outcomes, you've created ambiguity on purpose. Metadata follows: service, audience, region, risk tier, and last reviewed date. Make metadata mandatory in the content pipeline, because optional metadata is metadata that won't exist where you need it. Finally, design refresh cadence like you mean it. Policies refresh on publish. Known issues refresh frequently. Runbooks refresh on change. And you keep last indexed, visible in telemetry, because stale answers and hallucinations look identical to the user. Days 14 through 16, integrate MCP tools in read-only mode and enforce no source, no answer. This is where programs get tempted to move fast by making the agent do things. Don't, not yet. Start with MCP tools that only read, check service health, list known incidents, look up a user's open tickets, retrieve a service catalog entry, pull a ticket template. This makes the agent more accurate without letting it change state. And it gives you tool telemetry without operational risk. Then you enforce the grounding rule with teeth. If the response is non-trivial and there's no retrieved source, it refuses and escalates. Not a friendly guess, not based on my knowledge. A controlled refusal with an escalation path. This is also where you explicitly separate knowledge from action. The agent can answer from grounded content. The agent can propose an action, but execution only happens through a tool call and only after you hit a decision boundary. That separation is what stops helpfulness from becoming unauthorized change. Day 17 and 18, add approvals for write actions and introduce adaptive cards. Now you're allowed to add write tools, but only inside a governed pattern. Propose, confirm, approve, execute, log. Pick 1 or 2 write actions that are low risk and reversible. Ticket creation is the obvious one. Updating a ticket with context is another. Anything involving identity, access, finance, or deletion stays out. Adaptive cards in Teams become the approval surface because they force clarity. The approver sees who requested, what will change, why, and which policy applies. They click approve, deny, or request more info. No paragraph debates, no hidden side channels. And the card isn't just UX, it's control. The approval decision triggers a deterministic workflow, records the payload, stamps who approved, and then executes through the approved toolpath. If you can't show the approval record, you didn't approve anything, you just delayed it. Days 19 and 20. Red team prompts, injection tests, and tighten fallbacks. This is where you stop pretending users behave nicely. You test prompt injection. You test instructions that try to override policy. You test ignore previous instructions patterns. You test misleading inputs designed to force retrieval of restricted content. You test social engineering prompts that try to get the agent to generate an action it should never take. And you don't treat failures as model problems. You treat them as boundary problems. If the agent retrieved the wrong content, fix chunking and metadata. If it answered without sources, tighten the response policy. If it tried to call a write tool when it shouldn't, tighten orchestration. If it got stuck in tool retry loops, add hard stop conditions and escalation triggers. Now, the gate to proceed into days 21 through 30 is strict because this is where scale becomes liability. You proceed only when 3 conditions are true. Grounded accuracy in your evaluator set is above 85%, routing stability holds under real usage, and escalation rates are trending down for the right reasons. Not because the agent refuses everything, because it retrieves correctly, cites correctly, and escalates only at real boundaries. Once you pass that gate, you're ready for the final phase. Scale without panic. That means identity alignment, publishing discipline, and lifecycle controls that stop the ecosystem from rotting the moment it grows. Days 21-30 scale to a workforce without creating a liability. Days 21 through 30 are where leadership usually ruins the win. Week 1 and 2 produced a working system boundary. Week 3 proved grounding and approvals. Now leadership sees momentum and asks for more agents across more domains, more connectors, more autonomy, more channels. That request is how liability gets invited into production. So this final phase is not build more. It's make the first one survivable, then expand with discipline. Days 21 through 23. Align the agent with enterprise identity and least privilege. This is where Entra Agent ID stops being conceptual and becomes a dependency. The agent needs a stable identity anchor for audit, conditional access, and incident response. That identity also forces the uncomfortable question: what permissions does this agent actually need? And what permissions did it accidentally inherit because someone clicked allow all? So you do a least privilege review as a gate, not as a cleanup task. You separate read capability from write capability. You keep write actions behind approvals. And if the agent touches sensitive systems, you apply conditional access constraints that match reality, restrict where the identity can be used, restrict session behavior, and block high-risk sign-in conditions. This is where you prevent the classic failure. A helpful agent becomes a privileged actor without anyone explicitly deciding it should. Days 24 through 26, production ALM and controlled publishing. If the agent is business critical, it doesn't ship like a maker project. You enforce dev, test, and prod separation so you can change behavior without gambling in production. You publish through a controlled path so builders can't accidentally make something global. You lock down who can update the production agent, and you keep rollback real. If containment drops or escalations spike, you revert and investigate. No hero debugging, no late-night prompt edits in prod. And you formalize the you can build but you can't publish posture into a workflow. Publishing requires a named owner, named sponsor, tool allow list confirmation, grounding policy confirmation, and audit logging verification. Not to slow teams down, to keep the system deterministic as it scales. Days 27 and 28. Roll out to a target group with adoption tied to workflows, not training theater. This is where most orgs waste time. They run a Copilot training, teach people how to prompt, and then wonder why adoption stalls. People don't adopt prompts, they adopt outcomes. So you roll out by workflow. You put the agent in the channel where the work already starts. You give users 3 things: what issues it handles, what it will escalate, and what evidence it will show when it answers. That's it. Then you measure real usage, task completion without handoff, containment rate, and escalation reasons. If adoption is low, you don't fix it with more training. You fix it by tightening routing, shortening the answer format, and adding the next action buttons that remove friction. Days 29 and 30. Executive readout and the next 90-day plan. The executive readout isn't we built an agent. It's KPI deltas, risk posture, and operational truth. Show the baseline and the change, deflection, SLA impact, escalation reduction, and time saved. Show grounded accuracy and the evaluator set results. Show audit readiness, logging enabled, tool usage tracked, approvals captured, and identity anchored. Then show what you refuse to do, on purpose. No custom LLMs, no broad write permissions, no uncontrolled connectors, no agent sprawl. Executives need to hear that restraint created the result, because the instinct will be to remove restraint next quarter. Finally, define exit criteria before you declare victory. Success is measurable ROI plus audit-ready telemetry plus lifecycle controls that prevent sprawl. If any one of those is missing, you didn't build an agentic workforce. You built a short-lived demo with a future incident attached. And the last transition is the simplest truth in the entire roadmap. Agents don't scale because they're intelligent. They scale because you made their decisions enforceable. Conclusion. The law: replace work, don't imitate chat. The law is simple. Copilot succeeds when orchestration replaces work, grounding enforces truth, and identity enforces boundaries. Everything else is just sparkling automation. If you want the next step, listen to the next M365 FM episode on building an enterprise agent catalog that prevents sprawl without stalling delivery. Subscribe for more uncomfortable architecture truths about Entra, Copilot Studio, and the systems that quietly break when governance stays optional.